All right, in this video we're going to add another family to our organic chemistry, and that family is the carboxylic acids. Very similar to the alcohols, these have a characteristic functional group, and so attached to the rest of our hydrocarbon chain we have the end carbon, which is double bonded to an O, and then single bonded to an OH. So this whole group together, this whole thing, is what we call a carboxyl group. And that's the characteristic functional group that makes the carboxylic acids. Just like the hydroxyl group made the alcohols, the double bond made the alkenes, etc., etc. So this is the functional group that you're going to look for the carboxylic acids. The nice thing with this one is it's always on the end. It'll never be in the middle of a molecule in Chem 30. So the naming becomes very easy because we don't have to number anything. I always know that this is on the end. So in terms of naming, all I really have to do is find the name of the longest carbon chain, name it whatever it would have been if the functional group wasn't there. I drop the E, and I'm going to add on the suffix or the ending oic acid. And that's going to figure that out for us. The other thing I should notice, this functional group you've probably seen before in expanded molecular, for example in the molecule CH3COOH. So there's your C, your two O's, and your H. So the ending that we talked about in Chem 20, learning about acids, that something is acidic if it ends in a COOH. The reason it's acidic is because it has this carboxylic acid group, and that's what makes it acidic. This H has the ability to ionize with water and become acid. All right, so let's get out of that and do some naming here. So here I have a 1 carbon parent. Oops, let me switch screens on my iPad here. A 1 carbon parent. I have my functional group right here, C double bonded to an O and single bonded to an OH. So this would have been called methane if it was just a hydrocarbon, but now I drop the E, and because of that functional group it's going to be methanoic acid. Okay? Fairly straightforward, and these really don't get any more complicated than this. So here I've got a, let's see, how big is this one? We've got, oh, let me switch colors. 1, 2, 3, 4, 5, 6, 7, 8 carbons is my chain. I've got my functional group here, a C double bonded to an O and single bonded to an OH. So the name of this would be octane normally, but I drop that E, and this is an octanoic acid. Now there is a space in between the oic and the acid, so octanoic acid in this case. Okay, and our two more examples, but they're just as fast as the last ones. So here I've got 6 carbon chain, so that's a hexane, and I'm going to drop the E because over here I have a carboxyl group, so it's a hexanoic acid. And that's it. It's honestly, these ones are honestly that simple. Last example, we've got a line diagram here with a 2 carbon chain. Here's my carboxyl group. So this is a ethanoic acid. And that's it. So if you can find that longest carbon chain and identify that that carboxyl group is there, it's a little bit trickier in a line diagram like this just to see it. But if you can find and identify it, the naming itself is very straightforward, very easy. Okay, physical properties of carboxylic acids. They have a higher melting point and boiling point, just like the alcohols. Because of that carboxyl group with the OH on the bottom, they can do hydrogen bonding. So they're more polar, they have higher boiling points compared to non-polar molecules of the similar size. And up to 10 carbons, so decanoic acid, up to there, they're usually liquids, and above that they start to turn into kind of like wax-like solids. The smaller they are, the more soluble they are. Just like the alcohols, the bigger they get, the little bit less soluble they become in water. And because they are acidic, because of that structure, these will cause the pH of a solution to go down. So if you put them in water, the pH would drop. So like vinegar or something like that would cause a pH drop. Okay, some common carboxylic acids that you need to be aware of. Remember that this is part of what you need to learn in the course, is the identities of at least some common examples of all of these organic molecules and families. So something like methanoic acid is present in insect bites and things, sometimes called formic acid, and it's what like fire ants would have in their bite that causes that intense pain, is because they actually secrete acid into the bite and causes a lot of pain that way. Some insects similar have glands like on their stinger that would cause a lot of pain that way. Ethanoic acid we're very familiar with. It's vinegar. If you like salt and vinegar chips or putting vinegar on your fries, which is delicious, by the way. If you're not doing that, you should try it. But we use that in a lot of different things. Ethanoic acid is extremely common. Propanoic acid is used in antifungal agents, so sometimes for treating something like maybe athlete's foot or something like that. Benzenoic acid is a common food preservative in a lot of food items. And this one right here, its actual name is 2-acetoxybenzoic acid. You'll never have to name that. But its common name is acetylsalicylic acid, which is a lot of fun to say. Or its common name is ASA. And the brand name would be aspirin. So it's used as a pain reliever, a fever reducer, and a clotting reducer. So you may use it for pain or for inflammation. It's a drug used sometimes to help not stop a heart attack, but to help the clot not get any bigger during a heart attack. So it prevents the clot from getting any bigger. It's not going to thin the blood. Some people call it a blood thinner. It's not. But it will help the clot from getting any worse. They'll actually have the patient chew some aspirin to help with that kind of a situation. But it does have some side effects because of its acidic nature. If you use it chronically, it can cause ulcers. Or if you already have ulcers, usually they'll tell you not to take aspirin just because it can make those ulcers a little bit worse because of the way it interacts with things in the body. So there's your common carboxylic acids. The naming's really straightforward, but if there's anything that I've covered that maybe I misspoke or you're not sure about, you had trouble with, just let me know and I'll try to clear everything up for you. Have a good one.